Hi everyone, my name is Puneet. Today we'll study the basics of what is Spring Boot and we'll go step by step, add or actually use each of these features and try to learn about them step by step. So we'll talk what is Spring Boot. Spring Boot basically was designed and developed for people to have quicker development. Suppose you want to write a microservice quickly, you need a framework that will actually give you uh, a framework that will talk to the database, will actually validate that the constructs which you have around your beans or how you define the database in terms of beans is actually correctly in sync with the schema. You have a logging framework, and then you have your application server or web server. You deploy your code, and then all these bunch of things will in Spring is ready as you actually just download your first Spring Boot project from internet, and you will actually play around with all these frameworks within Spring, like Spring MVC, Spring Core, Spring Validation, Spring JPA, and develop your web service. So Spring JPA, just to give introduction, is used to communicate to the database, and it is implementation of one of the ORM tools called Hibernate. There are different ORM tools available in the market. We'll talk about what is ORM tools. If you don't understand this right now, that's perfectly fine. So Spring Boot basically essentially gives you the libraries that you will use to write your web service quickly and deploy them quickly, and then have a framework that if you want to talk to Kafka or ActiveMQ, you'll have your own dependencies which are available within Spring to do that. And suppose you want to do connection pooling, you want to initiate a connection to the database, all these things are handled by Spring behind the scenes, and you don't need to do anything. And JP also provides you a way that you just define what you want to do and do not write a query to read or write to the database. It will actually create a query on the fly, do the database operation, and give you the result back what you want. So what we'll do is we'll create a first Spring initializer project, which I said that as soon as you download, you're ready to start uh, creating your first Spring Boot application. So you go to this website, Spring Initializer, and I have been using Maven, so I'll go with Maven. You can use Gradle as well in case you are using. So this essentially will give you a sample project, and you say that you write Spring Boot class, and as we will add dependencies later on, because we don't need them right now because it's the first introductory classes. As soon as you say explode, it will actually take you to the project that will actually you'll able to download and then import in your IntelliJ. So these are the dependencies that wanted. If you see that it is a starter project and it does not have other dependencies which I was talking about, code or GPA and talking to Kafka or ActiveMQ, which are not there right now. Those will go step by step in import. If you look at SRC where your main code lies, you will actually go to you will be drawn to see this demo application.java. So this annotation basically annotates this class and says that this is the class which entry point. If you see, uh, there is a public static void main, and when you say that as soon as you run this as an application, it actually read the application properties files, application property file data, and then configures your application. Suppose in application properties file you have written the connection URLs or connection properties to the database, like where the database is username and password, and it will actually what do is it will actually create a connection for you uphand as soon as the application is brought up. And so we'll actually click on download about this, and then once it is downloaded, you will actually have to import it as a Maven project. If you just look at the JetBrains website, you will know there will be a way to how to import a Maven project. You just say file Maven project, and then it actually you go to the folder where you have downloaded and just select the pom.xml. Pom.xml is the XML that lists the dependencies which are needed by your application. As soon as you say open the project, it will actually take you in the screen, and this is the same project which I have imported as well. So what happens as soon as you run this, you will actually see that this code will get deployed as a Spring Boot application. and we don't have specified any board or anything. So it just started a Java project. And if you write something here about sysout or something, it will actually just run that. So we'll try to actually add a property, which is class name and which is a key, and then a Spring Boot basics. We'll try to access this property through Spring. So basically, if you want to do that with general Java, you will have to actually get to the path of this property, will read this property as a key, right? And then gets its value. So you create another class which will be of type bean. So you annotate this as a component. We'll get back to what is a component. So if you annotate a class as a component, what happens is that Spring treat it as a bean that it has to manage its life cycle. So you do not need to instantiate. You can just specify when this class is loaded. After the class is loaded, what happens? So what we'll do is we will have a post construct. We'll have public is a post construct, and you write a method public. So this will tell that this is telling Spring that when you instantiate this bean, what to do. So you'll say post work, and you will define what to do. So what here we'll do is we will actually import or we'll actually access the variable that we have passed in application.properties. We'll say dollar and we'll say the key name. Key name was class name. And we'll say private string class name. So, and here we'll see that we'll just try to print is class name. So as soon as you run this my demo application.java, what it will do is it will actually go through this package and see what are the applications which are of type component or service. So we'll come back to what is the service, and it would like to manage these classes. And we have defined here that post this class is constructed or this bean is constructed, you do this work. And basically this is the lifecycle management for this. So you will see that in Spring, you do not need to have to create objects of these classes. Everything is auto-wired. That means everything is instantiated for you. If you run this main class, you will have that printed. This is my first class. And after you accesses this, the variable name which you passed, which is Spring Boot Basic, is a value that got printed. So I'll just add a space. Yeah, so I think today we just learned about what is how to access an application.properties variable. In the next class, we will try to see further what is a bean and how to access the database. Everyone, today we'll see how to create an API. So what we'll do is we will create another package which will have controllers. So a controller is basically a component that helps you to control the flows. That means suppose you want to uh, query an API which is for persons, or you want to query an API which is for payments in future, right? So it specifically tells that with this URL you need to run this code. So as you see in URL, if you go to Stack Overflow, in the URL you add an ID of the article. So it takes you directly to that article. Similarly, here you specify the URLs like slash persons and say get all. It will actually go to the API which follows this nomenclature or URL and then get you the result. So we will add a class to this, which we will call as persons controller. So that means this class will have all the APIs related to person object. So now we will annotate it as a REST controller because this will have REST APIs. So we specifically tell Spring Boot that as soon as the application gets up, it scans all the classes for a REST controller in this package and tries to see that what are the APIs which are specified in this. So we specify that we have another annotation here, which is the request mapping. And suppose there are some APIs for persons and there are some APIs for patients who specifically tells that the DNS name slash persons, DNS name slash payments. So here we say that it will have all the APIs related to person object, right? And then we will add a sample API in this, which will just tell us that the server is running. So we say that we add a method which is public, it returns a string, and it says that the method name is server, and it does not have any param given by the user. It just returns server. And how do we call this particular API? Because this is a URL for the set of the APIs inside slash person, and then you'll have slash get all slash get person by ID, right? So we specify that this piece of code, which is inside this method, runs when the user hits a particular URL. So because it is a get call, we are not posting anything, we are not putting anything into the APIs. So what we do is we specify the path to it, which is, let's say, get all, right? So if from your browser you say localhost slash person slash get all, so it will actually return server right now. So now we will have another method just to show you that how to have separate APIs. Get all redundant, right? So the path changes so that this is how, like I'm just showing you how to have separate APIs. Okay. So let's run this class and let's go to terminal to see what it is saying. So the application is deployed on port 8080. And what we will do is so what I'll do is I'll say localhost 8080 slash go to the API and find how do we call that. So we will say slash person and we will say get all. So it returns server hyphen up. So if I want to call another API, the second method which you have written, we say get all redundant. And it returns the, the data which we have given in server admin2. So that's it for this. We will now, in the next lecture, try to see how do we connect to the database and query the persons table. Thank you. Everyone, today we'll see how do we connect to a database through a Spring Boot application, and we'll do that from scratch. But prerequisite is you install Postgres or any other database preferably Postgres, because we are following Postgres in this. So I had Postgres installed. You can look about how to install Postgres. When you install, you note down the username and password that would have you gave. So I created a new database which is training inside my Postgres, which is sitting on my local desktop. And so what we'll do is we'll again go to Spring Initializer, and we'll tell Spring Initializer what we want to do today. You select that as a Maven project, and then you keep everything the same. You add dependencies. We actually need dependencies as Spring Boot Web because we actually will be creating APIs in the same application and exposing them. So we need the already built libraries that will help us to do that. And then we will add JPA. JPA is a set of library that allow us to basically connect with the database, do our transactions, run our query, store and retrieve, change the data, right? So we will tell that we want JPA in our pom.xml as a dependency, and Maven will actually go ahead, download these libraries from internet and save it in your project. Then we need another thing is because we are going to connect with a database. If you're using MySQL, you will actually need the libraries which will be used to connect to the database of type MySQL. If you use Oracle, you need Oracle libraries for connection. And then we actually are using Postgres. So we need actually the connector or the driver basically for Postgres connection. So if you will click on explore, you will see that it has almost the same structure that was in the previous class. There is a demo.application.java that will actually is the main class that runs and then instantiates everything else, which is available in the database. We will have application.properties where we will specify the URL to the database, which will include where the URL is sitting. Is it on the local host or on another host, another machine on the network? What is the username and password? What type of driver we are going to use to connect to the database, and what is a dialect? Dialect is basically, you can say, a language of communication. So if you run queries against Oracle, or if you run queries against MongoDB or Cassandra, we need not to know what these are currently. But if for some people, if they know already MongoDB and Cassandra are NoSQL databases, the dialect means the way the queries are written or the way you communicate with basically the language of communication with the database is different. So you will specify what type of language, what type of dialect I will use. Okay. So click on download, and I already have this project downloaded. And then you go to the projects pom.xml and you go to open, and you say that I want to select this pom.xml of the downloaded project, and it will actually import this as a project. So now there will be a catch. So we'll learn one more concept today, that now if you run this application, it will not run because of the way Spring Boot works. We'll see how. So now what happens is that Spring Boot, what it does is, so if you look at the libraries of this project, you will see that we actually specified the JPA dependency. That means we are going to connect to a database, right? And if you want to connect to ActiveMQ or something else, it will be there. So Spring Boot does is it scans the class path and sees that what are the projects or what are the libraries which are already imported. So that means if you have JPA imported, so that means you are going to connect to the database, right? Unless you would not have been imported. So now Spring Boot's responsibility is to connect to the database, create a connection as soon as the application is booting up, right? When in case it is not able to connect to the database, it will actually say that I don't have a valid URL to connect to it. You will not be able to connect. So why it is not able to connect, first of all, is because we have not specified anything, right? In application.properties, it is empty. So we need to give that data. So what we learned just a minute ago is that Spring Boot auto configures everything, right? So in case you want to not auto configure everything at this point of time, you can just say auto configure class. You ignore that class. That will not look through the class path and then see what dependencies are there and then try to auto configure everything. So basically, you are deferring the auto configure. That will make sure that this application is run. So there are some different. If you don't do that, we will actually go ahead and write the connection parameters. So we'll say Spring dot data source is equal to JDBC Postgres QL localhost 5432. It is a port number. So we're specifying that create a JDBC connection to a database of type PostgreSQL. The IP address where the server is running, the database server is running localhost. This is the port number. And then the database is Postgres. For us, it is training, right? Spring Boot data source dot username is I have given Postgres, and then we will actually give the password. This is time consuming. You can actually look over the internet for the same keys that should be there for a Spring Boot application to connect to the database. So we are typing it. There's no Spring Boot, I think. That was showing us. So I'll just pause the video, just copy everything from Spring Boot documentation. So now I just had looked at the Spring documentation and configured everything. So the first thing is the first URL specifies the URL to connect to the database. You specify external IP instead of localhost or the DNS name if the server is somewhere else. This is the username and password for database, which is very basic. So this statement actually tells that if something is updated in the project, like the schema is changed on database, you actually go ahead and create it or update it. So we will just specify that as none for now. We'll not go into that. We'll do that later on. So SQL means that if you are running any queries towards the database, it will actually show the SQL on the console, the SQL statement in this console. And this is as we discussed that this specifies the dialect or the type of language that will be used to connect to the database. So as soon as now, if you run demo.application.java, it will connect to the database because now we have specified almost everything that it requires to connect to the database. There you are. So it actually deployed your application on localhost on Tomcat. If you see that I did not specified where the Tomcat is, it is embedded into the application. If we had written any of the APIs into it, it would actually expose those APIs on this port, and then it started the application, and then it connected to a database. So we'll actually see in the next class how do we run some queries toward the database, how do we create tables or define schema in the database as start. Thank you. So now we were trying to find a person by its ID, but we don't have any person object in the table, right? So we won't find anything. So first we have to write an API to insert. We will not do a direct insert to the table, but we'll write an API. If you see this method, it is a get API. Get is generally to get the data from the server. So the post is basically to actually post something to a table. That means that we are storing something to the table or to the API, right? So we send the request to the API, the post request, API gets it, and then it stores that to the database. So how do we do that? So we have another mapping, which is post mapping inside Spring Boot. So which also takes a path parameter. So because it is another table, right? So another API. So we say create is a URL by which we actually invoke this API. This is the URL for that. So we will write another method, which is public. It returns nothing as of now. We'll get later to it. How do we return after creating an object? How do we return a response of the new object to the to our response? So we'll say create person, and now we actually were passing path variable initially, right? Because in the URL we will specifying the ID we need to query. So here we will pass because post takes the data in the body. So there is another notation, which is request body. And it is of type person. So we'll pass person to it. And then what this method has to do, this method has to just use the repository and just say save the person as it is, what we get from the API from the client. So to call this API, we specifically need Postman. So let me install Postman, and I'll just pause the video for now. It's related have Postman. So this is the URL. If you see in the code, so first we have to give /person, and then this API is used by create, and in the body we pass the person. We'll see how do we pass the person in the body. If we go here, we will first fix the URL, and then if you see, just see that what are the properties of a person object. So ID is auto-generated. There is a first name, and then there is a last name. So we will use the property first name, because ID we need to pass because the database already creates it according to the constraint. And as soon as you just pass first name and last name, or first name or last name, in case both of them are not nullable. So we have to pass first name and last name both, and it actually creates a ID on the fly for it itself. So if we go back to the Postman, what we will do is we will select raw and say JSON, and ID we can skip. Just say first name Puneet, and then the last name. If we start this service, we'll create a debug point here, and then we just started. since we have created a debug point, we will try to inspect what the person is. So because I think we do not have the getter and setter for this. So why these properties are null? Because we don't have a way to set them because there's no constructor, because it is a bean, it has to have a getter and setter. So what we will do is we will say generate getter and setter, and we will do that for all of them. So if we now start this application again, then if we pass the same data again, so if we inspect the person now, so it has Puneet. So as soon as we say save, what it will do is it will actually do a insert query to this table. So it writes this object as it is to the table. So now we have seen that how do we pass the person object as a request body. The difference from the last thing was that there was a path variable, which we are not using now. So there are two different things, path variable and response body. Here we don't have a path variable. The path variable was ID, which we mentioned over here. Then this was a request body. So now if we stop this and just run the application and then try to see what's coming on the console after we try to reinsert the same object again. So now if you see, it actually ran an insert query to the table automatically. We have not written any query, and this repository which we have written earlier was extending the JPA interface, and then all the implementation of saving to the database are already provided to you. You don't have to write anything. So if we go back to the database and see if there are any rows which are written. So you see that ID has been generated automatically. We'll try to insert a new record and see if that comes with the same data. Or we will actually change the data to say K and K. If we query the table again. So this is automatically inserted and the ID is automatically generated for it because in the person entity, we have told that this is a primary key which should be automatically generated. So we are not providing any value to it. So it is auto-generated. If you see the body, we are not passing the ID, right? In the next lecture, we'll see how to query this table. Thank you. Hi, in the last lecture, we saw how to write an API. We wrote this simple API that tells us that the server is up and running. In case it is not up and running, it does not return server hyphen up it again. Essentially, throws 500 series error or 503 that the service is not up in case it does not. So what we will do now is, since we have this person table created in database, right, with long ID, first name and last name, we will actually try to retrieve the data from this table by writing a repository. So repository is type of an interface that can extend a JPA repository or a CRUD repository. We'll do that with the JPA repository first, and then we'll go to CRUD repository and see the other differences. So it actually extends those interfaces which already have the implementation of the basic operations, like find all the rows, like get all the rows, which means select star. Find a row by ID. So suppose you want to fetch a person by its ID, which say it is 101, it actually gives you the result back for that person, the complete row back, which is select star from the table person where the ID is 101. So and the other implementation, how do we update, how do we save, which is insert into all this implementation, all these queries are already done, and they actually get mapped to a very important thing which we discussed in the first lecture, which is a dialect. Because it is a Postgres dialect, it actually converts, it actually knows what is a query based on this dialect. So if it is Oracle, it has a separate type of query. If it is MongoDB, it has separate type of query. So what we'll do is we will actually create a new package which will have all the repositories that we will make in future. It is already there. Yeah. So I had already created this. So basically, this is a repository and it extends the JPA repository. If you go to the JPA repository's documentation, it has all the important implementations like find all by ID, save all. That means you are giving a list of person objects. You are having a bulk insert into delete in batch, delete all in batch, get one. That means get one by its ID, which is find by ID, as simple as that. So all this is a basic implementation which is already given to you, and then it also gives you the functionality about paging and sorting. So that means suppose you have 10,000 rows in your database for person object person table, you might not want to return all the 1,000 rows because it is very time consuming to fetch all these rows from that, because the database actually stores the database data into a disk. It is not in RAM. So the database server has to look through all the disk sectors where the rows are kept as flat files, and then fetches those and then returns you back. Also, 1,000 rows will have a large amount of data, which the Spring Boot application has to store, format in memory, and then return back the response over the network to the client. Client also has to load that. So what if the client doesn't want to load all the rows? It just want to like sort by the person name or first name or last name or by ID, and then it actually needs one first top 10 rows or top 125 rows. Then you can tell that, okay, I want to get the first page of by the sorting order of this page size. And then when you go to the next, you specify the page you want to go to. So we'll get to that later on. But first we'll write an API that actually gives you all the rows in the database for person table. So what we do is we will try to discuss AutoWire. So what is AutoWire? AutoWire means that the object of uh, a particular class will be automatically created for you. As you might have known that in Java, you need a new keyword. Basically, everybody uses new keyword, and there are some other ways also as well. But you don't need to use all the other ways currently. So what AutoWire does is, as soon as when you boot this application through demo application.java, it actually scans all the components or means which it has to instantiate. So for it, if it has to actually instantiate or actually give a person controller a life, it has a dependency that uh, we also, because this person controller has to actually fetch the data from the database, for which we will use person repository interface, which we have already created. So it actually needs a reference towards that. So a reference for that will automatically be created for you. You do not need to specify anything for that. So what we do is we will write another API. Public, give me a list of type person, because of this API returns you all the rows of person paper, right? So we have the return type as list of person. We say get all person rows in the database, right? So this is the API name. I mean the method name, not the API name. So what we do is we also have a get mapping, which was removed from here by mistake. So we have a get mapping that you specify the URL of this API. And URL is specified by path. You specify, say, get all. And then what you do is you say return repository dot find all. So we have seen that I have not written any query anywhere. Right? So as soon as I boot this application, it will look for all the beans it has to instantiate. So it comes here, it sees that the REST control, then it has to get all the references to the APIs, mount those APIs at port number 8080 for the user to access. So we'll go back to demo application.java. Okay, so this is up. And if we go back to REST controller, the person was the URL, and then we had specified by get all. It has to be small case, actually. So you see this, there was a query which was run, select ID, first name, everything from this person, right? So because we did not have anything in the database, it did not return anything. So that means we are able to run queries against the database through Spring Boot application. And in the next lecture, we'll see how to save or insert some data to the person table. Thank you. Hi. Today we'll see how do we update a row, because we have written only select queries, not deletes and updates. We'll see how do we write a new API which would actually update a record. The user would actually supply the first name and last name, and it will actually update the records. So as always, we'll write a new method for that because it is a new API. That now we see that we have been actually getting the records from the DB, and we have inserted here. And the difference is this is a post mapping that actually changes something into the database, including put. And then there is a get mapping that actually retrieves the database. So in case we will actually follow the HTTP norms because we're changing something which already exists, so that is a put. So if you look at the difference between post and put, post actually creates something, and put specifically tells that there is a location with ID 5. Go ahead and put this data now there. So put knows where to put. Post is you are just throwing something, and then it auto generates an ID for you for that in the database. Then put, if you rerun put again and again with the same data, it will not change anything into the database. Every time the query will be the data, the query that you say select start from for this key, the data will be the same. While for post, every time you post the same request, it will actually create a new row into the database because it generates a new ID primary key, and you pass khanna p, khanna k, khanna k, khanna k. All these rows will be inserted again. So this was the difference between put and post. So we'll go ahead and then say we are now going to update. So that has to be a put mapping, a put API. So we'll say the path will be date. We're updating a record. The string can change. You can pass anything. You can even pass your name. But then we will now write a method. It actually, let's say it returns the same person object that you are updating with updated data. You say update person. And here we'll actually pass what to update, right? So we'll say we pass a request param, and then we'll say that the request param is ID is of type log, because the if you look at the table, ID is basically log. So we'll say log ID. This can also be figured out from the person entity class, which represents the table, the database. So then we will actually pass some data into the body. So if we have already seen, if we are passing something to the body, we use this annotation. So we will just copy this whole thing. And then say the variable name person reference past or past. First, so right now we will just make it return null. So the user has to pass the long ID as a request parameter, and then it has to basically pass the data which he wants to change. So please note that since we don't want to change the ID of this record, so the client should not pass the ID. Even if he passes by mistake, sometimes we get and then we post again in the same request. So that time the ID which is passed should be ignored, or or you can validate if the person is trying to actually change the ID, then invalidate that whole request and tell the user that it is not allowed. So what we do is we do not just directly save this, because if you save this as uh, as this API, as this API is doing at line number 41, it will actually create a new record. So what we do is we actually retrieve, we say optional, or we will first retrieve. So we'll say that repository find by ID, because we know the ID user is passing it. And then it actually returns a person object in from the database. It returns optional, so we will do one thing. We will say then if the option is not null, specifically what we can do is right now to save time, we will say person dot get is the person object. We'll say optional person, and then we'll say so, so here you get a person reference. So what we do is we set the values which we get from the past data. We say set first name, which we get from the user. Get first name, and then we set the last name. So set last name. So we will save this new, because this new object now has the properties of the past data. So we'll say person from the database has to be saved. So we'll use repository. Again, repository dot save, and then person from the database. So since this gets saved, why do we not just return it from the and remove this null? So now let's stop the server, then restart the server in debug. See. So we are passing the ID. The URL is person/update. ID equal to, we will pick a record we want to update. Let's pick 5. Then we say the first name is change first name. The last name is and we will change the method to what. So we'll create a debug point here. Is everything okay? Looks so. So if we just see the past reference, which is change first name and the last name, which we are passing from Postman, and now the database has canine-k. We'll go ahead and try to just save this. Now, let's run that to see the logs. Too long. So we might have a constraint. We'll just say change effort. Change. So now it has actually executed that update. If we go here, we'll see an update query. So we had actually passed the first name and last name, what to set, then ID which we passed. So if we go back to the database and try to rerun this query, we'll see that the first name and last name was changed for the ID 5 with record. So that's it for now. Thank you. Okay, so we will complete the method to query the database, get the person object by its ID. So what we will do is we will we'll modify this method. It actually returns a person object, and then we will use repository again, where we say find by ID. So because it knows that it returns a person object, and we actually will give its ID which the user is passing. It is of type long. And then it returns an optional person. And then we will use optional to get the person object. If now we start the server and see if there are any problems along with it. So we'll note the URL, which is person/find and then slash the ID. So if you go, we'll pick any row, we'll say 5, and then we will move this method to 5. We are passing find ID by 5. So we are passing ID as 5. And then if we query, we actually get the same record back. Right? If you go back to the database and see, so we can actually move this method to provide a list of the IDs, and then we have to write a native query for that. We'll come back to that later on, but this is how we query a row by its ID, by its primary key. Thank you. Now, today we'll see how do we pass the parameter to the API. So let's say we want to, we're going to develop an API where we pass the ID of a person and it returns the person object. But first of all, we'll see how do we pass the ID to the API and how do we create that API. So we will write a method, public, it returns, let's say for now string, we say get person by its ID. And we'll write the implementation later on to this. So we'll say is the ID is so we'll define ID. So what we'll do is we will specify that this method takes a path variable that once you search in Google, you say q is equal to, right? Q is a path variable and the value towards q is uh, the the search text which you are passing. So basically, q is a question and text is what you are searching for. We specify there is a path variable which is of type string. We'll see that when we create the person object, this type can change to a custom object like person. And because this is a method that is an API, so we will define a get mapping for that because it is a get API. And we specify the path of this API, which is, let's say, find, and then we pass the ID. Cool. So now if we start the server, we will now try to pass an ID. So the API starts with /person find, say localhost 8080 person find. First, we'll see if the server is up. It is up, right? And then we will say find class 101. So it should actually return the ID is 101. So that means the API found that key 101 in a variable ID, and then it is able to return it. So this is how we actually return the we pass the variable to the API and we see that it is returned. In the next lecture, we'll move forward with this API. So in the last lecture, we saw if we pass the first name and the last name, you actually get a record returned back. So what if we omit the last name, because there can be a case that we don't know about it. So what happens? So it says 404 because it happens because in the URL we have mentioned that we will be passing the first name and last name. In case the last name is not passed, what happens there? So what we will do is we will mention this as required false. y is equal to false, then what happens? Let's restart the server. We mentioned that last name is not required in the URL, so just match it to the first name if the URL matches. So this cannot be there. So the server is up and we'll hit the same URL. Oh, so we just mentioned here, right? Data required is equal to false. Then why it is not taking it? Because the URL does not match. So the API actually demands that there has to be 3 strings uh, tokenized by slash. So it does not match. It does not find any URL. So we have to define here that there can be a case that this API can be called by 2 URLs in this case, that the user might not have the first name. So we'll pass an array of valid paths and we'll copy this whole array, the whole string, add and item, but this time we will omit the last name. So that means this piece of code will be executed if these 2 URLs are missed. So server found no problem with that. And then if we hit this will actually match with this type of URL. So if we hit this, it does not find anything with Khanna, which is the first name. And because it probably has passed null as the last name, right? So this is how we pass multiple params, multiple variables to the URL. But this there can be a number of URLs that we have to specify in case the number of params can change. So which is where instead of path variable, request params are beneficial. So if you search in Google and you will see that as soon as you hit enter, there will be a URL change and says that question is equal to ABCD, whatever you are trying to search with. So you anything after question mark, Q is equal to A is equal to C is equal to A, Q, A, C are actually the request variables, or what we say request params, which you are passing. So we'll go ahead and then basically change this to request params. Request param can be the first, and then this can be the second. And we'll remove this and we will change the URL. So we will not define anything and we'll just define by name and we'll pass first name and last name as part of the request params. So we'll go back to the URL, we'll change how do we send the request. We'll say this time the first name is not and last name equal to Q. So I think it's fine. So we will start the server. And as soon as we hit, we'll see that it has returned a record and it ran this query. So this was a difference between the path variables and the request params. Thank you. Right, we'll see how to delete a record from the database. So as we have put mapping to change something, post mapping for creating something, get mapping to fetch the data. So we'll have a delete mapping as well. So it specifies like what type of method it is in HTTP. So if you see that when it was a put mapping, the method type changed to put. So we will actually specify the mapping. Path is slash delete public delete. It actually returns void or no. Say delete person, and we are not going to pass anything in the body, just the information about what is to be deleted. So we'll say request param is again the same ID, which is of type long, and then we will use a repository, and we will there is a delete implementation already for this, and we'll just say delete. We'll first fetch the record which we want to delete. So we'll copy this thing. We'll name person. So get this is O. Now we have fetched the record from the database, and we'll say repository dot delete, say start this over. There is also I think delete by ID. First we will fetch the record. So find, just find say /5. So it returns as a record. So now we will use the delete API, this person / delete, and it is not a path variable, it is a request variable. So we will the name of the variable is ID. We'll use that ID is equal to 5. Change this to delete. Delete does not have a body. Delete this. And then hit enter. So if we want to get the same record again, 5, we do not get it because it does not exist. If we go back to the DB, run this query again, you see that the row with primary key 5 has already been deleted. That's it for now. Thank you. Right. So we know how to find a record by its primary key, but we do not know how do we search for a person matching rows with the first name and the last name. That if you go back to the database, if you want to search for Puneet Khanna or the row number, the row with primary key 5, how do I search for that in spite of having primary key with me? Because there are some scenarios we have to do that. You could know the primary key right there. So, or we want to know who are the records which have the first name starts with P or K, right? So how do we write those queries? So we go back to controller, write another API for that. So we'll say we'll start with public. It may return a list of persons. Please note that, because unless you know that there has to be exact match, which is not the case because two records can have the first and last name as the same. because there is no uniqueness defined on those two columns. So we'll say find by first name and last name. So we'll have two path variables. The first one would be for the first name and the second one would be for the last name. So we will change the, because the column is varchar, right? So we'll change the type, first name, and then for the last name as well. At this point of time, we will just return null. So okay. So now we always know that whatsoever the query related work has to be done in the repository. So we know that there is no method. We have not defined a query, but we do not have to define a query. That is the beauty of JPA. So we'll say because JPA exactly knows which variables are there in person class. If you go back to person class, which is an entity which represents the table, it knows that there is a table, there is a column by first name, and then there is a column by the last name. So it knows the column names. If you go back to the repository, and then you say that you write a new method for this, you say that it can return more than one rows. And you say find by, and then you always start as capital with the column name. So we'll say find by first name and also starts with capital, and then last name also starts with the capital. So we'll pass to this method first name and last name. So since we have written this method, there is no need to write the query. So Hibernate or JPA will actually rewrite its own query for this because it knows the database schema. So we'll go back to controller and just simply say the repository, and we'll use this method find by first name and last name. We'll pass the first name and the last name, and then we will try to start the service. So in case these things are not matching, the service will not start. The column names are not matching because it does not know what the query is. So all these validation is done when the service is booted up. So cool. So now we will call this API. The API, oh, we have not specified the mapping for this API. That means the URL by which this API will be called. We'll say path is find by name, and this will be first name is a variable name, and then we pass another variable, and this is a path parameter. We'll look at right. So this time we'll see that how to write a query. If you're seeing the repository interface, you see that all the implementation, all the interactions which we are doing with the database so far are already being implemented by JPA. That means the queries that have been used by us are provided by the repository. So how to guide the repository further in case the query which we are writing can be complex. So we'll start with the first query today, and then we'll see how do we write that in the repository database. So we will write another method. We will try to get all the records from the DB with a query. If you see, find all has its own implementation, but we'll give our own this time. So let's start with that. So it actually returns a list of the person. And we will name this as find all from them all using the query. So where do we specify the query now? There is a query annotation that you can annotate this method with query and write a query here, specify that what you are writing is very native to the database. So it is a native query. It is not implemented by Hibernate. So, but it is native to the database. We say that select star from, let's go back to see what is the table name. Table name is person. So P will add alias. So this time we will go back to controller. We will say, we'll write another method that says get all person from the database using query. And here we will use the method which we just wrote, and we'll change the API get using get by queue. Let's keep it short for now. Let's see if the server has any problem with that. So we will go back and use the URL which we have for this person. See if it returns all the records. So currently it returned 3 records. Let's see how many are there. There are 3. So this is how we actually write our custom queries here from the database, and we will dig deeper on this. Thank you. Okay. We see how do we pass a record by its primary key, but we do not yet know how do we get the data by the first name and last name. We know it through the repository implementation, but we have not written a query for that. That means how do we pass the multiple params? So it is quite easy. Let's dive into it. So we'll copy this method as it is, and then we will rewrite it. Find records by, we'll just say names, and the user might give the first name. We'll specify what needs to be passed to this method to get the record. First name, string, last name, and we'll modify this query because it is native. So we will say p dot will go back to the database, try to understand what are the columns. So first name, last name is school name. So we'll modify this where p dot first name, and we'll modify the variable name which is preceded by the column. We'll say and p dot last underscore name equal to column the last name. So we'll go ahead and use the variable name is strange. So we'll go ahead and use this method right away in an existing API that fetches the data by first name and last name. So I think this is it. So we will use this, and this returns a list of, because they cannot be the same. I mean, they can be the same. The first name and last name can be same for multiple records. So we will go ahead and try to see if this resolves this. We will stop the server and start it again to see if there are any problems. Meanwhile, we'll try to frame the query. So the API is find by name, and it is, please note, it is a request parent. So the first name and last name. So what records do we have first of all? So we have the same records. So we should get all three records. The first name is Puneet and the last name is. So let's see if the server reported any problem. No. Did it? Did we restart? Look at the API. So looks right. So what we have not seen is how do we pass the query params to this query, because the user might state that select the record where the person's ID is this, select the record where the person's first name is this and last name is this. So let's try that out. So we will go ahead and copy this, modify this, select star from person, and we will modify this query. Person P, where P dot ID equal to. So this is how we specify the variables. We start with a column and we say ID. Since ID is of type long, pass the ID here, and we say find the. Okay. So if we go back to person, database is person, and ID is this. So we will try to use this method. We will just this time modify the same API instead of writing name in interest of saving time. So it actually should return just in person. We'll go back here and we will just say return person itself. So let's restart the server after reviewing if everything is fine. So P is an alias of the table person. We said P's column ID has to be the past, which is the outcome. So let's restart. Let's get the API ready in Postman. Find. So we know we'll Let the fourth record. The server is up. It didn't find any problems with that. So ideally, it should just get us that record. So this is how we pass the params to a particular query. Further on this later. Thank you. Today we'll see how do we map a person table to an address table. That means from a person, we can actually get all the details of address. Address may have a string type of the complete address, then pin code, and then which country code it is. So address can have its further dependency on a country table with a country ID. The Because it is type of normalization, we will not have the complete string or all the columns of address in a person, and this is why we actually remove these or we deduplicate the data to a other table. But how do we map? So far we have been actually retrieving and be able to write the queries on a person table, just on a single table, update it and delete some data, right? But how do we actually pull the data from multiple tables in a single query? So for that, as a pre-work to save time, what I've done is I have actually created a address class, which is of type entity, and then I named or and rated this class that it will actually represent a table in the database by name address. So if you look at this, so the same name was taken, and then there are two columns, which is ID and address. IDs of is auto-generated and address is just a string type varchar, and then we have a constraint that it can have length maximum of 100 and it is not nullable. So and then I have created a address controller. Before that, I actually used address repository, which was created. I have given default implementation for address repository because I have not overridden or provided new methods for custom queries. So I'll use default find by ID save. And in address controller, there is one API which I have created by the URL address / create, by which I can create an address. So if we go back to the database and just say you want to retrieve all the rows and see what is in the address table, there's nothing. If we go back in person and see if there is anything, there's nothing, because I would like to draw your attention to another property, which is create. If you see say create, what it'll do is it will drop all the tables into the database. Very, very important to know that you should not do that in production. And then it will recreate all the tables with just the schema which you provide and without data. So what you generally do is you specify none at occasions, or you specify update. If there is an update, you apply to the database, and you specify none case you don't want to do any DLL or okay. So this is what I have done currently, but in this video we'll see uh, how do we map, how to get a person object, and with that, how do we get the address of the person as such in a single query. So what we'll do is we'll first specify uh, a column of type address. Please note that this is of type address. This is not of the default type which we have been using, which was supplied by the database, like string, varchar, long, int, right? So we have not been using that. So this is of type address. So now the database or the compiler will complain, since it is a custom object, you have to have a mapping, specify what type of mapping. By mapping, we mean that how do the rows of person and the rows in address map to each other. So in one-to-one mapping, we specify uh, by code that a person can have only one address and one address can have only one person sitting there. So that is one-to-one mapping. Many-to-one means that there can be many persons which can be related to a single address, which is a common case. So we will actually go ahead and specify what we're doing currently in this video. This video will go for one-to-one mapping. So if we actually go to the source code of 121, it has actually, you specify what is a target entity for person. What is a target entity? It is for this address column in person class. So it is address. Cascade all means that how the modification of the dependent table, which is person, and the address will have a primary key of the address, but it will be a foreign key in person. How do the deletes, if we delete a primary key in table, what effect it has in the tables which where it is a foreign key? Uh, what type of fetch we are going to use? By eager and lazy means that once you specify eager, uh, strategy, it means that as soon as the person object is retrieved from the database, it also, the query actually goes ahead in the address table as well, and then pulls the address data as well. And then you get the complete address. So by, and sometimes we will actually go for lazy in case the data is not really required to be used by the users. That time we will actually go ahead and use lazy, so that not all the columns are fetched. If there are, let's say, 20-25 columns in a table, and you don't want all of the columns to be fetched because the data is actually distributed at separate sectors on the disk. So in case the data is fragmented, the disk is fragmented, uh, the disk has to actually go to different sector, pick all the data, and then return it back to the API. So that is time consuming. To save time, to save resources, this is like you go for lazy in case you don't want those columns to be fetched. So whenever you want to actually fetch that uh, data, you actually will have hold the reference to person object, person row, or an object, and then you say get that column. At that time, that data will be fetched and returned back to the user. So by default, it is eager. We don't have to specify. But in case you don't want few of the things to be sent back to the user or be even read by the database, you actually say that it is lazy. That means it is on demand whenever it is needed. So, and we'll talk about map by in the next video. So we will, from these properties, we'll use cascade currently. We'll go back in person class and then we'll say cascade is of type, every operation will be cascaded. So if you modify the primary key in the main table, uh, uh, or it will have, or update or delete, right, what impact it has on all the corresponding join tables. And then we will, but we have not joined these tables, right? So as soon as I specify a join column, a new column will be created, because if you specify all these variables or fields which are there, right, they correspond to a column. So when this update will be flushed to the database, a new column will be created. So we specify that with a join column, that this is a column which is joining two tables. So if we go to the documentation of join column, we will see that the default name will be picked, which will be of combination of the owning entity and the entity which is mapped. So in this case, what is the owning entity? So a person is actually holding a reference to address. So it holds it, it owns it. But if you go back to address, it does not hold a reference to person. So in this case, a person is actually holding a address or a reference to the address type. So that means the person is a owning entity. So when, if we don't specify the name of the column, what we'll do is it will say person underscore address, which is not really readable in queries. What we'll do is we'll go ahead and name the column name that will be created in the database. We'll use name equal to, we'll say address underscore ID. So we are just storing the ID, but not complete all the columns of the address in this column, right? So which was a goal, that we should not have duplication of data in a person object. So old, because address can have, there can be 100 addresses in the table, but then there can be many persons in many to one mapping, right? So in that case, we don't want all the rows in person to hold all the data about 100 addresses they were mapped to, right? So the disk is safe. And then this is very important. So there's a field referenced column name. So that means what is a column name in address which is referenced by this join. So because this is a foreign key is address underscore ID, but what is the primary key it is mapping to? We'll go back to address and choose it. So because the foreign key is specified by ID at the rate ID is ID. So we will go back and then we will say that it will be mapped by the primary key ID. So now we'll stop this service and we'll apply the change and see if the there are some problems at runtime that JPA detects with associated keys. No problems. So currently we don't have any address as such, right? But there will be update which will be flushed to the person table, which will be, we'll say, refresh, and a new column has been created, which is of address ID. So if you go back to constraint, all the constraints which we have, this is foreign key that we just created. So this is how we actually modify the database schema by JPA. So now we don't have anything in person as well as in address, right? So we'll go ahead and add a person. So it is created. Let's go back and verify. So it is of ID 1. And if we go back to address, there is nothing in that. So how do we create an address? For that, if you go to address controller, there is address slash create. So we'll say address create. And what is needed for an address? So because it takes address as a body, so to pass address as a body in this API, we'll see what address is made of. Address is made of ID, which is auto-generated. We will not have to supply it in the body. And then there is a details column, which is of type varchar. So we'll go ahead and say the details are 3D406 ABC apartments AC Road. Yeah, I hope it is not writing in the sprint. So we'll remove first name because it is not a part of address. Then we will go ahead and say great. So if we go back to address, so we see that the complete data was saved and ID is 2. So how do we map, if we map ID to address to a person row of ID 1? So currently the address ID is null because we have not set it. So for that, there was an API written by me beforehand to save time. So we pass an address ID to map an address ID to map that to a person ID. So what I do is I fetch the person ID from the database and then the address from the database. We have not added these checks in the database that if the address is not valid or the ID is not valid, that we'll do later on. But to save time, we get the references to both the rows in the database. And then we actually go ahead and set the address. So if you go back to person object, so we can see that there is a address reference. So we have to set it. So for that, let's create a getter and setter that we did not create for address. So now if we go back to person controller, we say that on this object, set the address which is retrieved as this because the ID was supplied by the user, which is address ID. And with that, we found this row, this object. And then on the person object, which we also retrieve based on the information given by the client, we are actually setting the address to the person and then saving it. So if we hit that API now, we know that address was 2, I think, and let's verify it. Yeah, the address was 2 of ID2 and the person was ID1. So the person with ID1, we have to map the address of ID2. So for this, we will say address, copy this URL by which it will find which API to hit. So now, as we have seen before, so these are the request params. So we start with the question mark ID equal to ID was 2, which is a person ID, and we are supplying the address ID. Just copy this string and say that this is of 2, value 2. And then this is a put API, so we'll change the method name to put, and we'll delete this body because it is not needed. Not found. Add address. Oh, sorry, this is in person API because we are updating person, right? And so if we go back to the database and try to see that record, we will see that there will be address ID. It is, let me run this in a debug mode. Person controller. So we found person from the database, which is Puneet with ID1 and address is null. So if we have to see if it got the address was retrieved successfully by ID2. And then once we set the person from the database address, so we'll go back and see if the address is mapped here, but we have not saved it. So what we'll do is we'll click resume program, and then the address was mapped to the person object. So I think last time we did not because it was a pre-compiled code with half of the changes. So when we restarted, the compiled code was updated. So if we refresh the data in the database, we see that address 2 is mapped, for which the details are these. So this is unidirectional, that if you retrieve a person object, you will be able to get the address as well, like this, right? But how do we actually get the person from an address? So that is a reverse or inverse mapping, right? But this is how we do one-to-one mapping. We'll look at the other features in the next video. Thank you. In this video, we will see one-to-many mapping. So what I did is I created an employee class and then a stock class. So when a person joins, or the employer actually gives an employee stock as part of appreciation. or joining or their vested stocks. So an employee can have many stock allotments, right? So each stock allotment will be a separate table, and it will have an ID, identifier ID, and number of stocks which are allotted and the time of allotment. So this is what is representing a stock. So one employee can have many stock uh, allotments. Like one time in December 2022, there will be allotment of 30 stocks, and then in 2021 December there was allotment of 10 stocks. So an employee can have multiple stock allotments, right? So how do we do that? So we know that why it is one to many is because one employee can have many stocks, but if you look from stocks perspective, that is a many to one relationship. So we'll do a unidirectional relationship from employee to stock, and we will be able to fetch stocks from an employee object. So what we have to do is we have to go to employee class, and then we have to say private will be a list of stocks. This as stocks. So we'll say it is of type one to many, and cascade is of type cascade all. And then we will say if this is a owning entity, it's a joint column, and name will represent employee underscore ID. So, and then we will generate data setter for this. So what I have done is I created the employee repository as default, stock repository as default, and there's a employee controller. I have written methods to basically create an employee, get an employee by SID, allocate the stocks where the user will pass the ID of the user employee and the stock ID, allotment ID, so that these can be allotted to the user. And then create a stock. In interest of saving time, I just created a create stock API with the same controller instead of creating a new controller, because I just had a reference to stock repository, which was auto-add. Uh, so, uh, so what we'll do is we will go back in application.properties. We'll say create. We'll create the schema from scratch, and I'll say start. So what we will see is as soon as the service gets up, the tables will be auto-created with no data in them. So if we look at stocks, it created stocks with ID column and employee ID. So if you look at this, it is recommended that the many to one mapping is actually an owning entity, while currently we have one to many as an owning entity. How do we specify what is owning entity is that if you look at the employee class, the join column, the entity which holds the join column is owning entity. But in our case, one to many is owning entity, which is employee. Employee is one and many stocks. But it is recommended generally in industry that you should have many to one as a stock as a owning entity, because employees, let's say there are 100 employees, so how do you define that this employee holds this data? That information should be in the stocks table. So each stock should have a reference to the employee ID to which it is allocated, right? That's why it is recommended that many to one should be the owning entity, but this is just for learning, that I'm sharing how do we do one to many. So what we'll do is we will create an employee, and we'll go back to the employee table. See if it was created. So let's look at later on why full name was not allocated. So we got an employee ID as well. So that is what we wanted. We wanted a record. So if we go back to the repository, the idea now is to create a stock, and we'll allocate that later on. So uh, we will find an API to create a stock, which is slash stock employee slash create stock. Now, what is a stock holds? Stock holds the number of units, the time of allotment, which is auto created. So the database will actually create that date for you, which is the time of allotment or time of creation when the stocks were created. So let's say it is creation time. So now what we do is I think this column has to be date time of creation of stock or something, and then there has to be another column of time of allotment as separate. It shouldn't be creation timestamp. It should be, I think, update timestamp. Yeah. So as soon as a record is updated, that means it is allocated. It should be the database gives you a timestamp. So I think that's a bug currently. So you may like to fix it when I share the code with you. So if we look at this class, we only need to provide the allocated stocks. So we'll copy this key, say allocated stocks. We'll say 50 if you're lucky. So we will now create a stock, go back to the database and see if the stock was created. Yeah. So stock was created and time was auto inserted. So employee ID is not referred. So if you look at employee table, how do you specify that this employee holds these 10 stocks? It is not possible, right? Because this ID specified a uniqueness for an employee, right? So we will not have multiple records. So that's why it is recommended to have many to one as a owning side, but we have not specified that in the code. What we do is we will use an API which is allocate stock. So we'll go ahead and say allocate stock, and then it takes request params ID is the employee ID, and then it takes stock ID. So there's there's a stock with ID 2. So we'll give 2, and we'll go to the employee table and get the ID, it is 1. So we'll put it there. And I think it is of type put because we are updating a record, right? Post is to create a record, and put it is to update as a record. So what we'll do is we change the method to put, then we'll remove this, it is not needed. So primarily what it does is it actually fetches the employee from employee reference from the database, stock reference from the database, and then it actually just add your stock which you don't did and set the stocks to the employee object, and then employee we just save the employee and update the database. So now if you see employee ID now has a stock which is allocated to it. So this is how we do one to many mapping, and you may like to actually move the uh, joint column to many to one side, which is stock. I think that is easily doable. You should try it, but I'll later on create a video on that. Thank you. In this video, we'll see how a stock, which is having many to one relation with the employee, and employee which has one-to-many relation with the employee, has owning entity as stock. So how do you define an owning entity? We say an entity which has a join column. So we have created a reference of employee in stock, and we said that this is joining a column with an employee, and it is having many to one. That means a stock has many stocks can be allocated over to one employee. Then an employee has one-to-many relation with stock. So if you go back and see that initially we had join column annotation on employee, but at this point of time we have reversed it. So at this point of time, using the APIs, I have already created a stock with ID1 and an employee with ID2. So we will go ahead and try to use put. Let me restart the server in debug mode. Then let's create a debug point on the put method and see what happens. So here what I do is I get the reference to employee, I get the stock, the reference to the stock, which the user wants to allocate. Then I add a new stock to the already existing stocks of the employee, and then just update the employee reference. So I have just got the reference to the newly updated. I refetch this record from the database just for the debug purposes. So actually I could just do a return from here and that's all. So I think the server is started. So let's hit this API. So at this point of time, I passed the stock ID as 1 and the employee ID as 2. So here it fetched the employee ID, employee reference. So it has no stocks. I got the reference to stocks to update. I add a stock to the existing stock list. I set the newly updated stocks. Then I save the employee. When I get the reference back from the database, I see that there is one stock. And then in this, I will refetch this record from the database. So the updated employee has a stock of size 1. Go forward. And then I will try to refetch an employee with ID, which is 2. So I'll say find ID as 2. Change the method to this get mapping. And I hit, oh, it is a pathway. So I get this data and let's see if it has stocks. Yeah, it has stocks. So there is a mapping which is already done. So this is how we actually inverse and always have the owning side as many to one. I think that's all for this video. Thank you. Hi. If you look at this table of employees, you see that there is only one record. But if we query with a record that does not exist, let's see what happens. Let's start the service. So ideally, the API should tell the client what is happening, that the ID exists in the database or no. But in this case, let's see how it behaves. So it errored out and it says 500 internal server error. That means there is a problem at the server. But actually, in actual, it is a bad request, right? The ID does not exist in the database, right? So ideally, it should return 404. How do we do that and give a better response to the client? So what we do is from this APIs, if you see, we have been just returning the object directly. But instead, what we can do is we can actually return response entity. and that could be of type employee. That could actually hold a type of employee. So here what we're doing is find by ID, which is a default implementation of the repository, it returns optional. So we will remove this get and we will say that it is optional of type employee. All right, so let's return null for now to keep the code working. So if you pass 20 here, you will not find anything. So what we'll do is, if you will go to the optional source code, so it has few methods. If the object is found, it will actually, you can call null. In case you can call get, in case you call get on a null value, or optional that does not, is empty, does not have an arrow, it will actually throw no such element exception. Or you can say that if is present, that the value of the optional is not null. So we can use this method. We'll go back to our controller and we'll say if this condition is true, that means is present is false, right? So we will say return new response entity. We do not have anything to send, so we'll send an error message that says that there was no employee with this ID. So if you see that from the start, we have been following the HTTP standards. So in case anything is not found, we actually return 404, which is a 400 series error. 400 series error is, in this video, we'll see how do we add headers to the response. So what we have to do is we have to create the headers object, HTTP headers object, and say that headers dot add a key. And this is the accept header. Accept states that the client passes this, and it states that I accept a type of response that is XML or it is JSON, and then you pass that back again. So what we'll do is we'll add a custom header which says that custom example header, and then we'll have a value. We'll say well, just simple, or we can say ABC. And then what we do is in this constructor, we add headers. There's a overloaded constructor for this. And then we add headers here. We'll stop the service. We'll start and test our change. So we see we have given an invalid ID, and our custom header which we have added is added back to the response. And then 404 is the correct HTTP code, status code. The body states the correct message. Now we will pass a new ID which is actually existing in the database. Did we get this header? We did, because we are setting this header for both cases, right? So, and we get the correct body, and 200 OK is the correct HTTP status code. That's it for now. We'll look at the other things. Thank you. Hi, in this video, we'll see how do we run the queries in async mode. That means you issue a query and then you move on and do not wait for the response. So it is like you have an employee who works in the field and you call him and say that, hey, can you meet that customer and let me know what he feels about us. So, and then he goes out to work and you move on with your work. He calls you with the status after 2 hours, and then he says that the customer is happy, or and plus they have these concerns. So, if at all this was not the mode of working, you could have been waiting for him for the response. You could be on a call with him, or you could be on a call which is at hold. You have nothing to do, and then you will just wait for that query from your employee. So in case in our software, let's say there's a query that takes a long time. Let's say it takes around 20 seconds or 10 seconds, which is a very badly written query. So you would not want to wait for this because you have 10 more queries in an API to give. So let's say if we take an example of a person, uh, a controller. Suppose we want to get the list of all the persons and then all the dependent objects. So there are for some reason around 5 queries, and then you want to get the result of those 5 queries, add that into the JSON and return it. But what if the second query takes a lot of time, and then if that is the case, third, fourth, and fifth query will have to wait for uh, execution, and then the overall API time would be degraded. So in case your database server has a lot of codes, that means it can work on n number of queries, and it is scalable. You could go for an option where you can actually scale up the response time of your APIs. So what that option is within Spring, you will go to person repository, and then we'll annotate the method written by us as async. So, and then it is not mandatory to mention async